This place looks unreal. Almost impossible. A land where ice has compressed time into layers measurable in millions of years, where glaciers move with the weight of entire mountain ranges, and where the ground itself rises as ice melts, rebounding from pressure applied over epochs. Greenland appears as a convergence of frozen mass and planetary physics, more shaped by the accumulation of millennia than by the passage of seasons. Have you ever wondered why this island, caught between two oceans and locked beneath ice since before human civilization, remains one of the most climatically significant places on Earth? Why are its landscapes sculpted by cold, pressure, and gravity still challenge those who attempt to live within them? Most people know Greenland for its endless ice, its polar silence, its image as the last great wilderness. But living here means something very different. Behind the postcard image lies a place defined not by what humans built upon it, but by what the ice continues to do beneath it. Greenland is not just frozen water. It is a climate archive holding 18 million years of atmospheric history, a moving mass contributing to global sea level rise, and a place where survival depends on understanding forces that operate on timescales far beyond human lifetimes. This is not just a landscape. This is glaciology in motion. This is Greenland. Located 155 miles north of the Arctic Circle, Ilulissat Icefjord is a 31-mile system where one of the world's fastest glaciers meets the sea. Sermilik produces 10% of all Greenland icebergs over 35 cubic kilometers annually. The fjord reaches 2,300 feet deep, but a shallow 820-foot sill traps icebergs until they fracture or melt. Some towers up to 3,280 feet high and remain grounded for years. The glacier advances 130 feet daily, continuously feeding this obstruction. For Ilulissat's 4,500 residents, calving events create tsunami waves capable of reaching shore. Homes stand on bedrock above flood zones. Boat departures follow iceberg drift patterns. The sound of distant calving is ordinary background noise. The fjord formed through millennia of glacial erosion, carving deep coastal channels. The glacier has retreated over 9 miles between 2002 and 2023, exposing wider moraine fields and accelerating ice loss. Greenland's melting ice contributes approximately 20% of current sea level rise, with Ilulissat as a primary source. Tourism brings economic opportunity, but strains infrastructure designed for smaller populations. Places like Ilulissat remind us that landscapes under pressure transform the lives built around them. Scoresby Sund occupies 14,700 square miles of East Greenland's coast, the largest fjord system on Earth. The main basin extends 68 miles inland, before branching into multiple arms. The longest branch reaches 217 miles from the coastline. Depth varies from 1,300 feet in the main basin to 4,760 feet in certain branches. The entrance measures 18 miles wide, flanked by basalt cliffs rising 6,600 feet. Sea ice blocks the fjord mouth for 9 months annually, with ships entering only between late July and early October. Ittoqqortoormiit, the sole permanent settlement, holds 325 residents. Supplies arrive by summer ship delivery or year-round helicopter. Winter temperatures average between -8.5 degrees Fahrenheit and 5 degrees Fahrenheit. Hunting and fishing define the economy. Seals, narwhals, muskoxen, and polar bears form the subsistence base. The fjord system, formed through repeated Greenland ice sheet, advances during the Pleistocene, carving U-shaped valleys through intense glacial erosion. The most recent major advance occurred during the Salian glaciation, roughly 222,000 to 167,000 years ago. Climate change accelerates glacier decay, while expedition tourism increases during the narrow access window. Scoresby Sund demonstrates that remoteness is ongoing negotiation with forces beyond human control. Northeast Greenland National Park covers 375,000 square miles, larger than 166 countries. Established in 1974 and expanded in 1988, it occupies Greenland's entire northeastern quarter. Approximately 80% remains ice-covered, with coastal zones exposing tundra, mountains, and fjords. The park extends from 70 degrees N to 83 degrees N latitude, encompassing high Arctic and polar desert ecosystems. Zero permanent population exists within park boundaries. Approximately 40 people occupy seasonal research and military stations during summer. The Sirius Dog Sled Patrol, an elite Danish naval unit, patrols to enforce sovereignty. Access requires government permits via expedition ships or chartered flights to Ilulissat Icefjord Airport, 50 miles from the southern boundary. No roads, harbors, or commercial infrastructure exist. The park formed through millions of years of tectonic and glacial processes. Fossils from the late Triassic period, over 200 million years old, reveal ancient ecosystems predating current ice coverage. The park hosts 5,000 to 15,000 musk oxen, 40% of the world population. Arctic wolf numbers likely don't exceed 100 individuals. Access restrictions introduced in June 2023 limit expedition operators' range to protect wildlife as climate change alters ice coverage and access patterns. The Greenland ice sheet covers 660,000 square miles, 80% of Greenland, making it Earth's second largest ice mass. Average thickness reaches 1.2 miles, with some areas exceeding 1.9 miles. The ice contains approximately 8% of the world's freshwater. At its peak, the sheet rises over 10,000 feet above sea level. The mass flows outward under its own weight toward coastal margins. Kangerlussuaq provides the only global road access to the ice sheet. Point 660, located 23 miles from town via gravel road, sits at 2,165 feet elevation. The road, originally built by Volkswagen for vehicle testing, now serves tourism and research. The widening moraine track reveals ongoing ice retreat since construction. The ice sheet formed over millions of years through accumulated snowfall, compressing into layers. Gas bubbles, dust, and water trapped within preserve 18 million years of climate history. Current retreat rates exceed historical patterns. For Kangerlussuaq's 500 residents, the ice sheet moderates climate and provides research opportunities, but creates seasonal flooding risks. If entirely melted, it could contribute up to 23 feet of sea level rise. Surface melting creates moulins, draining water to bedrock, lubricating ice flow, and accelerating movement seaward. Disko Bay occupies Greenland's west coast between 68 degrees N and 70 degrees N latitude, measuring approximately 93 miles across at its widest point. Disko Island, spanning 1,511 square miles, features unique volcanic basalt geology with hot springs unusual for Arctic latitudes. Black sand beaches and columnar basalt formations distinguish the island from surrounding sedimentary coastlines. The bay receives 24-hour daylight from May 22 to July 24. The bay serves as a major feeding ground for humpback whales during summer months. Minke, fin, and occasionally bowhead whales also appear. Marine productivity peaks during the brief ice-free season, supporting whale populations and commercial fishing. Enormous icebergs from Ilulissat Icefjord drift through the bay, creating navigational hazards and tourist attractions simultaneously. For 4,848 residents, distributed across multiple towns, life synchronizes with seasonal light patterns and ice coverage. Summer brings fishing, tourism, and ship deliveries. Winter imposes darkness, sea ice formation, and reliance on stored supplies or air transport. Ancient lava flows created basalt cliffs and fertile volcanic soil, supporting lush vegetation, unusual for this latitude. Climate change affects whale migration patterns and fishing grounds, while tourism growth strains infrastructure designed for permanent residence. Tasiilaq occupies Ammassalik Island on East Greenland's coast at 65 degrees N latitude, surrounded by granite peaks reaching 9,500 feet. The town sits at the head of Sermilik Fjord, where three major glaciers meet the sea. The mountains exhibit sharper profiles than West Greenland ranges, reflecting younger geological uplift and active erosion. Ships arrive only 8 times annually between June and November. The region remained isolated from European contact until 1884, among the last Arctic communities encountered. Today's population of approximately 2,000 relies on hunting, fishing, and limited tourism. Access occurs exclusively by helicopter from Kangerlussuaq, a 15-minute flight. No road connections exist to other regions. Sermilik Fjord extends 60 miles inland, branching into multiple arms. The three converging glaciers, Helheim, Fenris, and Midgard, produce massive icebergs, filling the fjord seasonally. Depths exceed 640 feet in central channels. For residents, isolation is infrastructure. Supply chains depend on summer ship deliveries and year-round helicopter service. Medical emergencies require evacuation to Iceland or southern Greenland. Accelerating glacier retreat and unpredictable sea ice formation shift traditional hunting grounds. Increased tourism brings income, but strains limited accommodations and transport capacity. Ittoqqortoormiit occupies Liverpool Land on East Greenland's coast at 70 degrees N latitude, at the entrance to Scoresby Sund. The population stands at 325, Greenland's most isolated community. The nearest settlement lies 497 miles away across roadless terrain. Sea ice blocks ship access for 9 months annually, with arrival windows limited to late July through early October. A small airport at Ilulissat Icefjord, 25 miles away, provides year-round helicopter connections. Founded in 1925, when Denmark relocated approximately 80 Inuit families from Tasiilaq to establish presence and support hunting. The economy remains centered on traditional hunting and fishing, with an annual quota of 35 polar bears for subsistence use. Houses cluster near the harbor, built to withstand extreme cold and seasonal darkness. Polar night lasts from November through January. Winter temperatures regularly drop below -22 degrees Fahrenheit. Summer brings 24-hour daylight and temperatures occasionally reaching above freezing. For residents, isolation requires self-sufficiency. Supplies arrive by summer ship delivery or year-round helicopter. Stored food sustains the community through winter. Declining population occurs as younger residents migrate for education and employment. Climate change threatens traditional hunting patterns and sea ice reliability. Uummannaq Island sits at 70 degrees in latitude in West Greenland, dominated by a distinctive heart-shaped mountain rising 3,840 feet. The town of approximately 1,300 residents occupies the island's southern shore, facing a complex fjord system extending over 100 miles inland. The region contains multiple branching fjords, many remaining unnamed on official maps. Few vessels venture here due to ice coverage, distance from major ports, and navigation challenges posed by icebergs from numerous outlet glaciers. Founded in 1763 by Danish colonists, Uummannaq developed as a trading post, serving northern hunting communities. Today's economy combines subsistence hunting, commercial fishing, and small-scale tourism. Traditional culture remains strong. Dog sledding provides winter transportation and cultural continuity. The surrounding fjords exhibit active glaciation. Multiple outlet glaciers descend from the Greenland ice sheet, producing blue icebergs that fill the system seasonally. Water depths vary from shallow coastal zones to channels exceeding 1,600 feet. For residents, the fjord system defines movement patterns. Summer boat access allows travel between settlements. Winter sea ice forms highways for dog sleds. The heart-shaped mountain serves as a navigation landmark, visible for miles. Russell Glacier sits approximately 16 miles east of Kangerlussuaq along the gravel road leading to the ice sheet. The glacier forms a 197-foot-tall ice wall where an outlet stream from the Greenland ice sheet meets rocky terrain. Unlike Point 660's horizontal edge, Russell presents a vertical carving face, actively shedding ice into the preglacial lake at its base. The glacier advances at variable rates, depending on seasonal meltwater production and internal ice dynamics. The ice face exhibits layered structure, revealing annual accumulation cycles compressed into visible bands. Blue ice appears where air bubbles have been completely compressed out, while white sections contain trapped air. Crevasses form as the glacier flows over irregular bedrock, creating surface fractures extending hundreds of feet deep. Meltwater streams emerge from the glacier base, milky with suspended glacial flour, rock ground to powder by ice movement. The approach crosses moraine fields, ridges of rock debris deposited by the glacier's previous extent. The widening gap between current ice face and these moraines documents retreat within observable time frames. Summer melt seasons extend longer, producing greater runoff and faster ice loss. Sermilik Icefjord extends approximately 60 miles from its mouth, near Tasiilaq, into East Greenland's interior. Three major glaciers, Helheim, Fenris, and Midgard, converge at the fjord's head, each draining separate sections of the Greenland ice sheet. The fjord measures 3 to 6 miles wide, with depths reaching 2,950 feet in the central channel. Steep granite walls rise 6,500 feet on both sides, creating a confined space where icebergs concentrate after carving. Helheim Glacier ranks among Greenland's most productive by volume, advancing at rates exceeding 80 feet daily during peak flow. Calving events produce icebergs that ground on the fjord bottom, sometimes remaining stationary for weeks before fracturing or melting enough to float free. The narrow fjord acts as a conveyor, moving icebergs seaward as new bergs carve behind them. The fjord formed through repeated glacial advances during the Pleistocene, with ice carving the deep channel through granite bedrock. For Tasiilaq residents, Sermilik provides both resources and barriers. The fjord produces fish and seals, but iceberg concentration makes boat navigation dangerous. Accelerated glacier retreat and increased iceberg production create higher volumes than historical patterns. Tourism boats add traffic to already challenging navigation. Greenland does not end where the ice begins. It continues through frozen seas, compressed time, and communities that persist where others would not attempt settlement. These places look unreal, not because they exist beyond human reach, but because they demand a different understanding of what living means, one built on limitation, adaptation, and constant negotiation between survival and environment. The ice will continue moving. The fjords will keep producing bergs. The communities will adapt or retreat. What remains is the question not of whether these places should exist, but what they reveal about the relationship between landscape and life when there is nowhere else to go.